In this problem, we are going to look at number 19, and for the vector that's given in the initial point, we're going to find the coordinates of the terminal point and the length of the vector. So let's look at what this looks like visually. You don't necessarily have to draw it to do this problem, but I just kind of want to get an idea of what this looks like. So let's start with a y and x axis, and the position vector starts at the origin, so that goes back 3, 1, 2, 3, and down 5, 1, 2, 3, 4, 5. So the position vector looks like that. So that's a horizontal component of -3 and a vertical component of -5. But it's not the position vector. So this vector right here is that position vector. So it's got those two carrot looking things, like sideways carrots. And to tell us the horizontal and vertical components, which gives us the length and the direction of the vector. But this vector that we're given, so that's this guy, is actually the one that has that same direction and same length, but starts at the point 2, 6. So we're going to start at 2, 1, 2, 3, 4, 5. Right here, just barely fits on my paper. And it's going to have the same distance in both the same components, but starting from that initial point right here. So let me get a straight line tool. So I go, the horizontal component was -3, so I go back -3, 1, 2, 3. And then -5 for the vertical, so that's 1, 2, 3, 4, 5. And that gives me, this is V. So that's vector V. So I can see on the graph, I can see that this terminal point is, x is -1, y is 1. So I can answer that question graphically, but I don't actually have to do the graph. I can do this algebraically by thinking of starting at that point and then following these components. So my x is going to be starting at the initial point of 2 and then going back 3. So -3 gives me, so add -3 gives me -1. And the y, I start at 6 and I go -5 from there, so that's -5, which equals 1. So I can see that my ending ordered pair will be -1, 1. So two different ways to do it. You can do it graphically or algebraically, and you get the same terminal point. So that's our terminal point. Now we need to find the length of the vector. And that, I'm running out of colors here. Let's do it in light blue. So that you can look at this as kind of like a right triangle or a Pythagorean theorem. So I think the magnitude of V, which is I write with the vector name with the absolute value bars, shows me the magnitude or the length. That equals the square root of the horizontal component squared plus the vertical component squared. So that's the -3 squared plus -5 squared, which is 9 plus 25, which gives me square root of 34. So that's my magnitude. And that's, let me get my answers here. This is my terminal point, and this is my magnitude. So my terminal point is -1, 1. And my magnitude is radical 34.